Hello everyone and welcome to the new event from Data Zen Community. My name is Alexander Dunaev and I'm a host for this session. Today our guest is Manish, expert in data, and he will share an interesting talk about Delta Lake optimization techniques. So today you will hear everything about Lakehouse, Delta Lake and Databricks. Before we start, I want to remind you that you can ask questions in the chat. So please use this opportunity to make the session more interesting and cover uh, topics and sites that you're interested in. So let's start. Manish, floor is yours.
Hi everyone, thanks for joining. So let me introduce myself. My name is Manish Pansari and I'm currently working as a lead data engineer with EPAM system. So I have total 10 plus year of experience and EPAM I'm working from last 4 years and 5 months. Here I got opportunity to work on the multiple domains. One of the domain is like healthcare, life science. Then I got an energy domain. Currently I'm working on the manufacturing domain and I'm using PySpark and Azure as my primary skill sets. In my Azure journey, I am using Databricks, Data Factory, Data Lake Storage, Delta Tables, or Key Vault. Apart from that, I have done multiple certification on the Databricks. Some of the certification is Spark 3.0, then Data Engineer Associate, Data Engineer Professional Certification, and recently this year only I got the Solution Architect Championship from the Databricks itself. So that's all about myself. So yeah, let's discuss the topic for today. So today we are going to use the Delta Lake topics here for this presentation. This will be a basic intro kind of session here where we are going to use some optimized commands that can help our Delta tables execution process. So before starting deep dive on those commands, I just want to give you some highlights about how Delta Lake works. So basically, the Delta Lake is an open source project that enables a lakehouse architecture on top of the data lake. So, what was the need of delta tables? Previously, we have data lake. We can store the data into Gen2 location or S3 location. Then we have a concept of data warehouse where we can get the ACID transactions. So the hours of need was like we should have a system that can have a data storage on the file system as well as the acid compliance. So Delta Lake is solving these problems. You will have storage of files and you will have acid compliance tables as well. Now, on the interesting part, it is like you can save your files on multiple location. The location could be S3 or in Azure, you can save the data into ADLS Zen 2 location. Then you have global, I mean, in your Google Cloud, you can also store, or for the on-premise solution, you can store the data into SDFS. So basically, Delta Lake provide you the ACID transactions over the file system. Yeah. So before going to deep dive in those commands, just want to give you some basic principle of the delta lake. Here we have two type of files. If you are working on a delta table, if you store the data into delta tables, you will see two type of files. We will see those files in demo as well. The first one is Parquet files. The Parquet files actually store the data, and the other one is the delta log files. The delta log files contains the data, the metadata, or all the transactions that are happening here. Let's assume you have created a delta table. You are inserting the records, so the data, the actual data will be present in the Parquet file, but the insertion operation, all the information about the insertion or the creation or the deletion of the data, that will be stored in our delta logs. Parquet file actually represents the data, where the delta logs represents the metadata or the transactions. Okay, yeah. So here in this picture, you can see that the delta lake consists of two type of files. The left side file is Parquet files that consist the data. The right side file is the delta log files that consist of the transaction logs. Okay. Now I want to show you some information about these files. Yeah, I think you are able to see the screen, right? the notebooks. Okay.
Yeah, yeah, it's visible.
Yeah. So here I was just going, I will go with some basic commands here. The first command will be like how we can create the Delta Lake tables. There are multiple way to create a Delta Lake tables. The basic way here is like you can create by using SQL statement where you just have to provide the statement like create table, then you have to provide the table name and the columns. I'm running this here. You can see. So the table has been created. And if we use a describe detail commands here, you will see what is the table property, just like in SQL. So if you see here, what we'll see, the table type is delta, then the name of table here, you can see it's a high meta store, the catalog, then schema is default here, that then the table name. And you know that for every delta table, a location is stored. So we are not provided here any location. So by default, it will use this directory user hive warehouse, and you can see after that our table name here. So this is the one way you can create the tables. The other way is like you can use the data frame API just like this. What you can do in that part, you will have to use the write operation. The data frame API has a function write function where you have to provide the format delta. If you provide the format delta, it will store the data in the form of delta tables. Here you have to provide the location as well. So here in this process, we are creating a delta table with the help of data frame API. Let me run this command. So our table has been created. We have run SQL commands here for creating the table with the help of the location. We can see the data here as well. So for the initial load, I have created the delta tables with 3 records only. As we are saying that uh, at the start of this presentation, like delta tables has two type of files. One is Parquet, which is data storage. The other one is logs. So if we check the storage of this delta table, we can see these two type of file as well here. You just have to provide the ls command, and you have to provide the path of the table where the data has been stored. Now, now here you can see that we have one Parquet file. This is the data storage file, and we have the delta log files. If you deep dive in the delta log folder as well, you will get there are two type of files will be available in the delta log. Let us check. So now we are going into delta log folder. We will see here we have one JSON file, then the other one is the CRC file. All the metadata related things like this is the create table operation, or this is the like update operation, we can see here in the JSON files. Now the CRC file is a checksum file. It is used to avoid the redundancy here. Mostly we have to see the data here in that JSON file. So if I use this location, and if we check the JSON file here, we will get like how this table has been created. Yeah. So here, if you see what type of information this JSON file is containing, it is saying that user is me, then what type of operation we have performed here. We have used the write operation while creating the delta table itself. So this type of detail we can get from these JSON files as well. Coming back to our slide here once again. Yeah. So here you see that a delta table consists of two type of file. Now, what will happen in most of the cases? We have to deal with the optimization. So here in this session, we are going to discuss with three optimization techniques for the delta tables. The first one is optimize, the second one is ZORDER, the third one is vacuum. Apart from that, we have other optimization techniques as well, that is auto optimize or the liquid clustering. We will discuss those topics in our next session. Okay, here let's discuss about the optimize. Basically, it is used for the file compaction. There will be a scenarios like, let's suppose you have a delta table and you are running operation on the delta table daily, three times a day, let's assume. So what will happen in the delta table, like if you are inserting any records, if you are deleting any records, or if you are updating any records, what delta table internally will do, it will not delete the files or it will not update the files. Instead of that, for any operation, delta table will create a new file. That means, let's suppose if you have one file that has the information, the id. Now you want to update the name of that id. Instead of updating the name in the same files, delta table create a new file. So the point here is like, for every each and every single operations, delta table will create a new file. There is a logic behind that, because in the delta table we have the capacity of time travel, that we can go back of the version and we can check the previous data as well. So for that point, every times if you are doing any single operation, it will create a new file. For time being, let's suppose that you are working on that delta tables, and it's assuming that, let's assume that it's around 1 year or 2 years. From as the time goes, you will have multiple files for the same table. A simple table can have more than thousands files. So what optimize will do here, optimize will handle the small file problems. If you have more small files, if you have to scan too many files, then there will be overhead on the delta table engine. So to eliminate this overhead, to reduce the number of files, we have a concept of optimize. It is just file compaction. You have to optimize the table, you have to provide the optimize command to the table. It will merge all the small files into a larger one. Now you can set the size limit for the larger files as well. By default, the size of larger file is 1 GB, but as per your use case, you can increase the file size or you can decrease the file size as well. So basically, optimize is handling the small file problems. In our delta table engine, they have to scan too many files for the large tables. If you use optimize, it will convert those files or merge into one. The default size is 1 GB, and you can change the size. Basically, optimize is doing three type of operation. The first one is file compaction, merging into small files into a larger one. The other part is like metadata cleanup. That means like, if you have 1000 small files, you have to check the metadata for every single files that has associated with that table. By using optimize, we will the final product will have a single file, so you have to maintain the metadata of a single file instead of 1000 small files. The states update, basically, behind the scene, delta tables take the states of every individual files. Assume you have 5 files. What delta table will do, for every single files, delta table will check what is the mean value, what is the maximum value, what is the count of rows that are available in 5 files. Now if you have 5 files, delta table have to maintain this state for all the 5 files. Instead of 5 files, if you have one files, you are merging this one into one file with the help of optimized. Delta tables have the states of only one file, so it will again uh, the less overhead as compared to our previous files. Now here in this example, you can see that before the optimize, we have four Parquet file, four source file or data file here, and we have only one JSON file that is uh, writing the transaction logs. After the optimize command, you can see that here the four storage files has been clubbed into a single one, and now we have a new delta log file or the JSON file as well. So here in the new JSON file, there will be transaction logs like we have performed the optimized file on all the four storage files here. That can type of info you can get here. So again, I'm sharing my screen so that I can give you the example here how optimize is working. I hope you are able to see again the code editor. Now, in my previous delta table, we have we have three records. I'm performing a write operation. Here you can see that the number of affected rows is 1, the number of inserted rows is 1 because we have inserted a new record. If you do the update operation, the number of affected rows will be 1, but the number of inserted rows will be 0 because we are doing the update on the already existing record. I'm again adding a new data here for our existing delta tables. Again, we'll get this info. I can check the data here. Okay, this is the versioning. Let me check the data here. Yeah, here. So at the time of table creation, we had three records. Now we have inserted two records here, Amit and Manish. After the insert operation, you can see that we have multiple version of the same tables as well. The zero is the first version here where we have done the write operation. One will be the another version where I have inserted one records. Two will be the latest version we have where we have inserted the next records. So you can see that for a single table we have three versions, and you can see what operation we have performed on each version. Previously, as you can see here, we had only one file at our source location, right? The one data file. When now we have done two operation, two insert operation. Let's check what is the number of output files here for our same delta tables. Now you can see that we have three files here. Previously it was the single files, this one. Now we have two more different files. It is because we have done two insert operation. So my point here is like we have just given two operation here. We have two files for, let's suppose we are doing multiple operation on a single day for multiple days. We will have a lot of files, more than 1,000 files that can give us the overhead. So what we are going to here is we are going to use optimize command. Let's do the optimize. For using optimize command, you just have to write the optimize and you have to provide the table names. Yeah, if you see here, we get the info like num files added 1, num files removed 3. That means we have removed the 3 files, we have added 1 files here. You can see the length of files, minimum value, maximum value, average, total files, all type of info you can get hit here. Let me check the data, how the files are looking at our backend. So it should one files, right? Let's see. Now, if we are doing optimize command, the question should come here is like why we are able to see 4 files. It should be one files, right? As I told earlier. The problem here is like if you are doing a optimize command, it will remove all 3 files, combine the data into newly created one. So here the file number, this file, and this file is the old file. Optimize has created the new file here. The thing is like these 3 files should not be here, but Delta Lake is retaining these files as well because we have the property of time travel. As I earlier explained, we can go to the previous version. If Delta Lake will completely delete these files, what will happen in that case? we will not be able to do the time travel, we will not be able to go to the previous version. So here optimize command has created the files, and we have three base files as well. Problem here is like, if we don't want these three files, how we will do that? So we will discuss it later. We will use the vacuum command for that, and we can remove these three unwanted files. Okay, let's again go to the vacuum command, how it is working. Before going to vacuum, we have another command that is z ordering. We'll discuss it as well. Yeah, so now you have the problem statement, like even for after doing the optimize command, we have the previous existing files as well, and we have a new merge file as well. We will discuss this later after z ordering. Again, how z ordering is working, or what is z ordering actually. You know that whenever we have one file in Delta Lake, the Parquet files, Delta Lake collects the states of the file. It will get the IDs. Basically, it will get the states of all the first 32 columns. That means, let's suppose for the delta tables you have 100 columns, it will get the states of first 32 columns, and the states will be like that: what is the minimum value of the primary key, what is the maximum value of the primary key, what is the total number of count of the records in that file, what is the null value of that file. So all the states delta label is collecting for any files. What will happen if we minimize the data scanning? If I have to provide a query, let's suppose select star from table where id equal to 4, and we have 100 files at the backend. What delta will do, the delta query execution will do, it will use the file stats here. It will not scan the file, it will go to the file, it will check what is the minimum value of the id, what is the maximum value of the id, and the query in which we are using, the id in which you are using in the query, it will check for that id. If id is residing in that file, then only it will scan. So what z ordering will do, it will order the data, just like the sorting in the sql. Z ordering improves the effectiveness of the data escaping by the ordering the data. It will rearrange the data in a sorted manner. That means it can be from id 1 to 100 or 100 to 1. On the basing, I mean, you have to provide the name of the column in which you want to sort the data. So here in the z order, you can use z order command with the help of optimize as well. Basically there are two type of process that z ordering is doing. The first one is the order the data on the basis of column. You want to sort the data in files with the help of your primary key, you can provide the primary key and you can provide the z order command. The other one part is like, you z ordering is also update the states of the delta log. So the command will be here is like, you can use z order with the optimize command. You have to provide optimize, then the table name, then z order by using which column you want to do. Here in this example, our table name is delta table, and in the example I have used the id column here. I will show you the example for better understanding as well in the next slide. Here, if you see the excel here, let's assume we have a delta tables having id as primary key. Without applying the z order, let's assume for this delta table, we have three files at our backend. File 1 contains the record of like 1, 4, and 6, and file 2 contains the record of 6, 4, 2. File 3 contains the record of 7, 3, 4. As I already told you, like delta tables or delta log consist what is the minimum value of file, what is the maximum value of file. So for file 1, the minimum value of id will be 1. For file 2, the minimum value of id, maximum value of id will be 5. File 2 minimum value will be 2, maximum value will be 6. And for file 3, minimum value will be 3 and the maximum value is 7. Assuming we are doing a select star statement from this table where id equal to 4, that means what delta table will do, it will check, go for file 1. It will check 4 is residing between mean and max for file 1. It will scan this file. Again, it will go for file 2. It will check 4 is coming between 2 and 6. It will scan the file 2. Again, it will go for file 3. It will check 4 is coming between 3 and 7. It will scan the file 3. That means whole three, all the three files has been scanned by delta table here. Now, after doing the z ordering, if we apply the function like z order, what will the resultant output? On the right side, you can see with the z order, file 1, the data is sorted. You can see 1 2 3, then file 2 will have 2 4 4 4, file 3 will have 5 6 7 in the sorted manner with the help of z order. Now the file 1 has minimum of 1, maximum of 3, file 2 has minimum of 4, maximum of 4, and the file 3 has minimum of 5 and maximum of 7. Now, if we're firing the query like select star from table where id equal to 4, what delta table engine will do? It will check for file 1. 4 is not coming between the mean and max of file 1. It will just skip the file 1. It will go to file 2. It is checking like it is residing in file 2. It will scan the file 2. Again, it will go for file 3. Now, 4 is not coming between 5 and 7. It will not scan. In first case, without z ordering, we have to scan 3 files. In second case, with z ordering, we have to scan only 1 files. So this advantage you will get with the help of z order. You have to scan less files, and you will have a less overhead on your metadata, or you will have more your computation plan will be more optimized as compared to your previous one. I hope this example is clear. Now, the third command or the last command for this session is vacuum. We were discussing that after the optimize command, we should have just one file, but we were having three existing files as well. So how we will delete those files which is not required for us? In this case, vacuum is an important operation for maintaining the health of our delta lake storage. With the help of vacuum, you can delete all these files which is not required for your project. Basically, optimize will merge all the files in a single one, but it will not delete the file. The deletion part will be done by vacuum. With the help of vacuum, basically you can get three benefits. The first one is storage reclamation. That means over the period of time, your storage will have multiple files. With the help of vacuum, you can delete those files. You can save your storage cost. You can save your query execution cost while scanning the files. The second part is metadata cleanup. Again, by deleting those files, we will remove the metadata of those files from our data query execution as well. The third one is performance optimization. You don't have so much files. With the help of vacuum, you are cleaning up those files, so you don't have to scan those files as well. So you will have a performance optimization as well. Okay, again, here I'm attaching a screenshot. Let's assume that you have a file where you have two Parquet data files and you have two JSON files. Let's assuming we are inserting the data or appending or deleting the operations, or doing this type of operation here. Over the time, we will get more files. With the help of vacuum, once you will do that, now all the remaining files will be deleted, which is not required, but you will have a more JSON file that will give you the transactional information that you have performed the vacuum. But the data file will be one only. The process of doing the vacuum operation is like you have to follow the command like vacuum, then the table name, then retain, then you have provide the hours. In case of 0 hours, that means it will delete all the files, all the versions. You can provide the, if you want to delete the data older than 7 days, you can provide 172 hours as per your business needs. Let me show you the example again so that we will have more understanding on vacuum. Here, what I'm trying to do, I want to delete all the files. Basically, you have to use one property like retention duration check. If you want to vacuum the data for all the versions, that means for 0 hours, you have to make this property false. I'm running this property. I'm doing the vacuum command on our tables. It is done. So before vacuum, you can see here we have four files. I'm running vacuum here. The command completed. Now I need to check the data here. Now you can see that we have only one file. That means we have deleted all the three files that was not required for our previous version. And if you see the history of this table, now all the versions will be gone or deleted because we have cleaned up all the files. You can see here in version 4, we have started the vacuum. In version 5, we have ended the vacuum. So basically, the all operation we have done here, this is the summary of the operation we have done earlier for this table. In version 0, we have created the table with the help of data frame API. In version 1, we have inserted one records. In version 2, we have inserted again a new record. So for these three operations, we can see the right operations that is completed. In version 3, what we have done, we have used the optimize command that three files was merged into a single file, and we had four files at the backend. In version 4, we have started the vacuum, and in version 5, the vacuum has been completed. So all type of information we will get here from the history as well. You can see the number of you can see the mode, or you can see the status here as well. All the information you can get from this describe details or the history tables. Just want to show you one more thing here, which is very important here. Here in the vacuum, you can see that how many files we have deleted. It is showing that type of information as well. Like we have deleted three files. Once the vacuum has been completed, we get this info like number of deleted file 3, number of covered directory 1. Here we are not doing any partitioning on our table. That's why we have only one directory. Let's assume that if you have a delta tables that contains multiple partition, so once you will run the vacuum, it will go for each and every partition and it will delete the files as per the retention period. So that in that case you will get more directories, number of directories here. Yeah. Okay, let me come back to slide as well. So now the conclusion is like vacuum is used for removing all the unnecessary files as per our project need or as per our business requirement. If you are doing a vacuum, you will not be able to do the time travel. Whereas optimize will do, it will collect all the small files, create a larger one files, but it will not delete the previous files. What ZORDER will do, it will use the data skipping. It will order your data with the help of your provided key, and it will remove or trying to reduce the number of scanning process here. I have attached some useful materials here as well. If you want to deep dive on these commands, you can go here. These are the standard documents provided by the database itself. You can use those documents and you can apply the practices in your workspace as well. Now, I'm ready for the questions. If you have any questions, we can discuss.
Yeah, thank you very much, Manish, yeah, for this session. Now let's move to the questions. We have them. So first, how often should teams run a vacuum command, and what are the risks of its overlooked?
Right. So basically, it totally depends upon the project requirement. I'm just giving you one example. In my previous project, what we have to do, we have to retain the data of last 2 months. So we were using vacuum, all the data which was greater than the 2 months period. So it's totally depends upon your business requirement, what project is doing. Here in there is a concept of retention period, right? In case of disaster recovery, you can use the retention period data. In my previous project, it was 2 months. In the new project, it's going discussion is going on, but again, it's totally depends upon the use cases. Now the risk is here. So to avoid the risk, let's assume that if you are using a vacuum command directly on the tables, if you're not sure that how much file it will deleted, how many files it will deleted, and you want to be sure that what files will be impacted by this vacuum command, there is a concept, a beautiful concept here is like you can use the dry run. So if you're providing a vacuum, you can use vacuum table name, the dry run. So before actually deleting those files, you will get a list of files that can be deleted with the help of vacuum dry run. Yeah.
Yeah, and one more relating question. Um, Sorry, I missed it. Yeah, what's the best practice for automating these optimizations for a table with thousands of data daily? Is it a good practice to include optimizations to the notebook itself or create a new scheduled job just for optimizations?
So yeah, that will be fine. I think for my understanding, the best use case will be like you create a different notebook job. You can use the optimize command there, because optimize you will not run optimize on the daily basis, because first you have to create the files, multiple files. The best practice is like if you are doing a optimize on a smaller files or a less number of files, it will not give you the prior result, or again it will be heavy operation in that case. So the frequency you can set like for, I mean, the best practice is like the output file should be 1 GB for each merged file. You can calculate like how many small files in your project is giving you the optimization of a resultant file of 1 GB. Best practices like upon that, maybe once in a month or twice in a month, you can set up the optimize command as in a separate notebook. So that will give you more visibility, or it will be more optimized, because you will not run this optimize command on daily basis.
Mhm. Okay, clear. Also, related question. Vacuum is deleting files and history. How about if I would like to still have balance between housekeeping and keeping historical data for security complaints? Example, HIPAA that should be stored for 6 years. So, what's the best practice here?
Yes, so the drawback of vacuum is like, if it is, I mean, if you run the vacuum command, there is no way that you can get back the data. Now there is a more concept that is available in delta tables, that is change data feed, CDF. This is advanced concept I haven't discussed yet. You want to do the vacuum on the tables, and you want to keep history on that part as well. There is a concept of CDF, change data feed. Once you will apply this concept in your delta tables, even if you're doing a vacuum, but you will get what type of changes you have done on that your table. But the best practices here is like, if you're not sure that, like, if you want the data for the historical or timetable purpose, you will just not use the vacuum command, because after the deletion of file you will not get the data. There are other things as well, like you can have a shallow clone or deep clone, where you can copy the data in different tables, not on your primary tables for the data archival, and then you can use the vacuum on your primary tables. So in your previous table or the backup table, you will have all the data, but on the primary table for the query execution, faster query execution, you will have less data. So these are
Mhm.
the way you can use.
Yeah, okay. Thank you for good, interesting ideas. Yeah, maybe there are some tools or dashboards that you can recommend for monitoring Delta Lake performance over time.
Yes. So right now the thing is like, for the performance you can include Azure Monitor here with the Azure Databricks, where the delta tables, there are multiple matrices there. You can customize your delta tables matrix as well. So basically I'm using Azure Databricks, and in our team we are using the Unity catalog as well. In the Unity catalog you can use the quality, or you can use different matrices for your required delta tables. So I would recommend go for Azure Monitor with, if you're using Azure Databricks in your case, or in Unity Catalog you can get more idea about the matrices as well. You have a list of matrices you can use there, like a delta table storage is going far beyond your threshold. That type of alert you can get.
Mm-hmm.
Yeah.
Okay, got it. Is there a situation in which that order is still better than liquid clustering?
Yes, the problem here is like yeah, I haven't discussed liquid clustering for the wider audience, but
Mhm.
just want to give you some very basic about idea about in which case liquid clustering will be better from G order. That I'm giving trying to giving it you. Let's assume that we have a file have a data frame having 10 MB of data only. You are doing partitioning on, let's assume, state column. State has, you have 30 state in your country, and you are doing a repartition 5. That means you are storing the data of 10 MB in 30 partition with repartition number 5. That means for every individual partition you will have 5 files. You have 30 partition here. So for 10 MB of data we have 150 files. This is not the right case, I think. In this case, Z order optimize will not help. In this case, we will go for liquid clustering where Databricks or the delta table engine will do the optimization. Z ordering will be helpful in that case where you have like where the changes are not very frequent, where I mean we don't have too many small files. In that case, we will prefer Z order. But again, the liquid clustering basically handling the small files dynamically, that I would say.
Mhm.
Yeah.
Yeah, one more question. What kind of tables do you vacuum typically? Ingestion layer or like raw layer or log tables or anything else? So yeah, or maybe everything.
Yes,
Yeah.
yes. Yeah. So again, I was saying that in my previous project, we have defined the retention period as per our use case. That was 2 months. So all the tiers in my previous project, we were using medallion architecture, raw layer for the landing data. Then we have the history layer. We were maintaining all the history, and we had the transformation layer. So basically, we were performing the vacuum on the transformation layer where the that was exposed to some business people as well. So we have selected identified which tables we are going to use for vacuum. Yeah, so
Hmm.
typically this transformation layer table having more data that we were using for vacuum.
Okay, got it. Uh, yeah, I don't see any other questions. Yeah, I think we can conclude our session. Yeah, thank you very much, Manish, for the session and for the demo and answering all the questions. Yeah, thank you very much, everyone, for joining today. Yeah, if you like the session, or maybe if you don't like it, you can rate this talk, give Manish badge on the event page. So I pasted it in comments. Also, stay tuned. Wait for our new events. So we're already working on our next sessions. So thank you very much. Have a good day. Yeah, thank you very much, Manish.
Thanks everyone. Thank you.
Thank you. Bye.